Hi everyone. So this is the video session about the timer 8253, which have been interfaced with the 8085 processor. Hope the screen is visible. So in this session, we are going to discuss, and I'm going to tell about the block diagram of 8253 timer. So which is one of the interfacing, peripheral interfacing with 8085 processor. This 8253 pin diagram has 24 pins. So the pins 1 to 8 consist of the data lines, that is D0 to D7. The 9th pin is for clock. The 10th pin is for output. 11th pin is for gate signal. 12th pin is the grounded. 24th pin is the supply. 23 is write. 22 is read. So these are all the control signals. 20th pin is for that is A1, and 19th is for A0. Clock signal, 3 clock signals are available. So in the 9th pin clock 0, 15th pin clock 1, and 18th pin clock 2. And output ports have 3, that is 0, 1, and 2 in the pins 10, 13, and 17. Gate signals are 3 signals, 3 pins are collected. So these are all the pins which is available, that is in pin diagram of the 8253, totally 24 pins present. So the block diagram of the 8253 is here. So the center one is the internal bus. It consists of 3 counters. The name of the counters is counter 0, 1, and 2. The data bus buffer, read write logic signal, that is control logic, control word registers are also available. So the control word register helps to initiate the counters 0, 1, and 2. In each counter, the signals which are available is clock signal. In the 2 input signals are clock and gate. The output signal is 1, which is mentioned as out 0, 1, and 2. In the read-write logic signal, it consists of A1 and A0 and A1, and the chip select, read and write signals are connected. So in the data bus buffer, the D0 to D7 data lines are connected. So this is the block diagram. These are all the things which is available in the 8253. So the first one, the clock is input for the counter. The counter is always 16-bit. So the maximum clock frequency is 1 by 380 nanoseconds, or it may be 2.6 megahertz. The minimum clock frequency is DC or static operation. The next one is the out. This signal output line is the signal. That is the final programmed output of the device, which is receiving from the 8253, the output signal. The actual operation of the outline depends on how the device has been programmed. That is based on the instruction and how it is programmed, the output signal will be available. This input regarding the gate, this input can act as a gate for the clock input line, or it can be act as a start pulse, that is initiation of the process, depending on the program mode of the conductor. Each counter is identical, that is all the 3 counters 0, 1, and 2 are identical, and each has 16-bit resettable down counters. Each is fully independent and can be easily read by the central processing unit. When the counter is read, the data within the counter will not be disturbed. This allows the system or your own program to monitor the counter values at any time without disrupting the overall function of the 8253. So the counter selection is based on this tabular column. So in case of the counter 0, when the read signal is enabled, that is active low, the remaining all the control signals are in 0 position. It loads the counter 0. When the read signal is active high, yes, and write signal is active low, at the time the read counter will enable. Likewise, in the counter 1 and counter 2 will start its operation. The mode word or control word, when the write signal is active low, the write mode of the word is starts. Then this is the thing which helps to understand the counter operation, that is counter selection. What will happen when the input, that is read write logic, will stays, it will reflect. Then next, the control word register. This internal register is used to write the information about that is prior to the device, what we are going to do the process in the counter, sorry, in the timer. This register is addressed when A0 and A1 inputs are logical ones. The data in the register controls the operation mode and the selection of either binary or BCD counting format. This registers can only be written to. You cannot read information from this registers. So this is the control word format, and these are all the different uses of 8253 gate input pins. There are various modes of operation, that is mode 0, 1, 2 and 3 up to 5. These are all the modes of operation. So in the mode 0, interrupt on terminal count will be happened. The counter will be programmed to an initial value and a watts counter counts down at a rate equal to the input clock frequency. It is about the 8 megahertz. When the count is equals to 0, the output pin will be logical 1. The output will stay at a logical 1 until the counter is reloaded with a new value or the same value, or until mode word is written to the device. Once the counter starts its counting process, the gate pin can also be disabled the internal counting by setting the gate logic to logical 0. As in the mode 1, it is a programmable one-shot mode. In mode 1, the device can be set up to give an output pulse, that is an integer number of the clock pulse. The one shot is triggered on the rising edge of the gate input. If the trigger occurs during the pulse output, the 8253 will be re-triggered again. As the mode 2 is the rate generator mode, and mode 3 is the square wave generator mode. Mode 4 is the software triggered stop. The mode 5 is the hardware triggered stop. That's all about the 8253 timer. Let's we see in the next session. Thank you.